Hi, everybody. We're going to be reviewing today in ALEKS Topic 6 or Module 6, and we do have the Module 6 test coming up this week on Thursday. So I'm going to try to go through 5 problems in this video, and then I'll go through 5 more problems in another video as well, and then you can go through and check out any of these problems in ALEKS, and hopefully it'll help you in being able to figure out exactly how to solve these problems and what each problem is looking for. So anyway, in number 1, we have system A, system B, and system C. We have 3 different systems of linear equations, and as you know, those can be graphed on coordinate planes. And for each system, they either have one solution or they have infinite numbers of solutions or no solution. And we're looking at these graphs, and can we determine by looking at these graphs what the solutions are? And right away, I'm noticing system C is the only one that has 2 lines that are intersecting, and you can see them intersecting right here at this point. And so that means this system here has exactly one solution. So I'll click that, and then right here it's asking me to put the actual solution as an ordered pair. And this ordered pair is going to be the location of this point right here. This point, if you start here at the origin, you can see you go 1 space left and then 1 space up. So it's located at -1 and then at +1. So I'm going to put those values in here, -1 and then over here +1. Now, these other graphs, if you see 2 lines that never intersect, these 2 lines here are parallel to each other, they have exactly the same slope as you can see up here, -1/3. That means each of them is going down 1 as they go right 3. These lines actually are identical to each other, except one is going through +4, the other is going through -4 on the y-axis. And so what we have here is no solution. There can't be a solution because there is no shared point that these 2 lines have in common. They'll never cross each other, and so there is no solution to that system of equations. The middle example here, system B, has just a single line on the graph. And the reason for that is if you were to add 3x to each side here of line 2, you'd get y equals 3x minus 3, which is the same as what we have for line 1. These are the same line. So you graph them, and it's the same line, and since they are the same line, they share every single point along this line in common. These 2 equations do. And so that means there are infinitely many solutions to this one, and that's what I'm going to mark. Notice you do not fill in any ordered pairs when there is no solution or when there are infinitely many solutions. The only time you fill in the ordered pair solution to the system is when these lines are intersecting at just one point. Okay, let's move on to the second example. All right, here is a system of equations, and we want to graph this system here. And then once they are graphed, we're going to write the solution to this system. Now, if the lines are parallel, then we'll know there is no solution. If they end up being the same line, then we'll have infinitely many solutions. And as I look at my equations, and you will have different problems pop up when you're working your way through ALEKS. But when I look at mine, I notice these both have the same slope. Remember, equations are written in slope-intercept form, and my stylus will not write on the screen here, unfortunately, so I can't show this. But if you look here in front of the x, this is where you find your slope, and right now nothing is shown there, so that means there really is a 1 here. And so this has a slope of -1. The second equation also has that same slope, -1/1. They have different y-intercepts though. This one goes through -5, and yes, -5 is the same thing as plus -5. This one goes through -4 on the y-axis. So they're going through different points on the y-axis. The y-intercepts are different. So if I go to graph these lines, the first one, I start with my y-intercept of -5, and I'm going to put a point there at -5 on the y-axis. And then since my slope is -1, which is -1/1 when expressed as a fraction, From this point, I got to go down. I need to go down one space and then one space to the right. Then I'll place that second point. Then using my line tool, I can click those so they pass through those points, and there's my first line. The second line has the same slope, but this one's going through the y-intercept of -4. And I'm not even going to use the pencil tool this time. I'm just going to use the line tool. Here's -4 on the y-axis. And then using the slope, which is -1/1, I'll go down 1, right 1, plop a point there. There's my second line. And as you can see, these lines look identical, except one's going through -4, the other is going through -5 on the y-axis. So since these lines are parallel to each other, there is no solution to this system. So instead of putting in an ordered pair, I'm going to select no solution for my answer. And that's how we do number 2. Okay, now that we get to and notice here as you're working through the review, every time I complete a problem, see how it says try another down here? You can do as many problems as you wish as you're practicing and reviewing for the upcoming test. All right, let's look at number 3. Now we're going to start using what's called the substitution method to solve these. And this will be a little bit tricky here because I cannot show this on the screen. The stylus won't write for me. But I wonder, give me 1 second here. I'm going to open up another Smart Notebook page so I can actually write on the screen here. While that's loading, let's take a closer look at this problem. We have y equals x minus 11. Underneath that, it says y equals 14. Well, if both x minus 11 and 14 are equal to y, then x minus 11 has to be equal to 14. And so I can write that down. And so I'm going to do that right here. I'm going to write down x minus 11 equals 14. Okay, and let's look back at the original problem here. X minus 11. Let's see if I can snap these so they're both showing on the screen. There we go. And since x minus 11 equals 14, oh, gotta open that back up again. Another way to look at this is you could actually, since y equals 14, you could substitute 14 into this top equation in place of this y here and write 14 equals x minus 11. That's the same thing as this over here, just written the other way around. To solve this, you can see I'm going to have to add 11 here, which means I do the same thing on the other side of the equation. And then the minus 11 and the plus 11 are inverse operations. They cancel out. And I end up with x equaling 25. All right? And that's all I'm asked to find on this one is what is the value of x? So in this box here, I'll enter 25. And I'm pretty certain I have that right. We can always check it. Take 25 minus 11. Does it equal 14? And it does. Just also to reassure you on the test, you may use a calculator if you wish. You might not need it on every problem, like on this one, for example, you wouldn't have needed it. But you may use a calculator, and you'll also need scratch paper, both when working on this review and when taking the test, because you will have some work that you will need to show on some of the problems in order to solve them. All right, number 4 is pretty similar to number 3, except now I have to find both x and y. Both of these are written in slope-intercept form. I see I have y equals 6x plus 8. And then below that, I have y equals 9x minus 4. Okay, these have different slopes, so I already know I'm just going to have a single solution here. So I'll be able to find an x value and a y value for this. Since both of these are equal to y, I can set them equal to each other. 6x plus 8 has to equal 9x minus 4. Now I'm actually going to write it the other way around, and I have a reason for that. Here I'll write 9x minus 4, oops, that's kind of messy, equals, and then I'll put 6x plus 8 on the right side. The reason I'm choosing to put the 9x minus 4 on the left is because there's a larger coefficient there in front of the x. 9 is larger than 6. And the reason that's nice is because for my next step, I need to get rid of one of these terms that has the x in it. And so I'm going to remove 6x by subtracting it here. 6x minus 6x is 0. But that means I also subtract 6x over here. And notice what happens is I end up with positive 3x here. And it's on the left side of my equation. I like that. So I have my x's on the left, and it's positive. So 3x, I still have the minus 4 here, and that equals 8. I still have the 8 over here. Now I just have a two-step equation. I want to get the x by itself, so I'm going to start by removing the minus 4. I'll add 4 here, add 4 here. The reason I do this first is because I want this variable term, the 3x, to be isolated or by itself. 3x equals 12. 8 plus 4 here is 12. And then my final step is to divide by 3. And 1x equals 4. So I know what x equals. If I come back over here, I can put 4 in for x. Boom, there it is. And now if I want to find y, all I need to do now is substitute 4 in, either in place of the x in my first equation or in my second equation. It doesn't matter which one we use. Let's try the top one. Y equals 6x plus 8. I'll write that down here. Now I know x is equal to 4, so let's put 4 in for x. Y equals 6 times 4 plus 8. So y is equal to 6 times 4 is 24. And then 24 plus 8 is 32. So y equals 32. And that is my answer for this box right here. I'll type in 32 here. Okay, you can check these answers, 4 and 32. Test them in this other equation. 9 times 4 is 36. 36 minus 4 does equal 32. So it's checking out in both equations. All right, I'm going to do number 5 here, and then that'll wrap up this first video. 5 is just like number 4. This time, though, we have y equals 4x plus 11, and then y equals x plus 38. There is actually a 1 in front of the x here. Don't forget about that. Since these both equal y, they have to equal each other. And let's put 4x on the left since it has the larger coefficient. 4 is larger than 1. So I'll write 4x plus 11 equals, and then I have x plus 38 on the right side of my equation. That's, again, that's really 1x there. So let's subtract 1x here, subtract 1x here, because I do not want x's on both sides. And 4x minus 1x is 3x. 3x plus 11 equals 38. Then I want the x's to be by themselves, so let's subtract out 11. This is gone, and we have 3x equals 27. And then my last step here is to just divide each side by 3. X equals 9. And again, once you have your value for x, you can substitute it in. Either equation is fine to find y. The second equation is really nice here because it simply says y equals x plus 38. So all I'll need to do is just substitute 9 in for x here. Y equals 9 plus 38. And again, I apologize, this is a little messy. And so y is equal to 47. There it is. And then I enter these values in over here. X is 9. Y is 47. You can substitute these in and see if it works out in the top equation. If x is 9, 4 times 9 is 36. 36 plus 11 does equal 47. So it works there as well. All right, so that's it for this video. I'll do numbers 6 through 10 in the next video.